lesson video for 8.2, so find that page in your notes that looks like this, multiplying a polynomial by a monomial. You did a nice job on the material from 8.1 where you were learning to add and subtract expressions, and today we kind of put that together with what you have from your exponent rules so that we can multiply expressions with a monomial, meaning a number or a term that's sitting out in front. So when you look on the first example, we see that the monomial sitting out in front to be distributed is that 6. That's that monomial that we're about to multiply by the trinomial that you see right here, by that 3-term expression. Now, we're going to have to be careful that when we're in multiply mode versus add-subtract mode. So right now when we're distributing, we want to take that lovely distributor, that 6. We want to distribute it. We're in multiply mode because distributors are multipliers. So we're going to take 6 and multiply it by our first term, multiply it by our second term, and multiply it by our third term. On the first one, we're going to write out each part of the process, and on the next ones, we'll see if we can do some of that multiplication in our head. But please grab your calculator for numerical calculation that you want to double check. So in this first one, I have to multiply the 6 by the 4y squared term. And if you don't mind, I'm going to put a dot between the 4 and the y squared. Then I bring down that subtract sign, and I need to multiply the 6 by the 9y. So that's going to be a 6 times a 9 times a y minus, and then I'll have to take again that 6 multiplied by the 7. You may or may not choose to write this much out every time, but for people struggling with it, I think this is a good place to go because you tend to get them right. Now we need to see if we can make each term simpler. So when I look at the first term, I do know how to multiply 6 by 4. That'll be 24y squared. And the next one, subtract. I do know how to multiply 6 by 9. 9 times 6 is, oops, I almost wrote the wrong number though. 9 times 6 is 54. And then our y minus and the 42. So our final answer now will be done as long as we can't combine any like terms. So we were just multiplying, so we need to get our brain wrapped back around the fact that we're done multiplying, and now we're looking to see if any like terms. So I see y squared terms, I see y terms, but we know those don't add together. So therefore I've got mine in standard form with my y squareds first, my y's next, and my constants last, so this one's finished, and it's as simplified as we can get it. In the next one, our multiplier then, by everything in the terms, is a 3x. So that's a 3 dot x. So as I do these, I want to really be aware of whether I'm multiplying or dividing, whether I'm adding or subtracting something, so that I don't mix up my processes. So in this next one, I'm going to suggest we write it out the way we did the first time, and I want to see that on homework for people who are struggling with this. So first I'm going to write out that I need to do 3 multipliers. And then I'm going to put every bit of that multiplication down first, and then I'll worry about cleaning it up. And most of you found success when you did that with the other things with exponent rules. So this one becomes a 3 times x that has to get multiplied by our 2 times x squared. All of that's in that first distribution of the 3x. Plus, in the next distribution, I already have a 3x to distribute, and it has to multiply by another 3x. Keep in mind you can pause the video if you need to catch up or to try it yourself first and then come back and compare. And the last part, I need to multiply the distributor 3x by the 5. So when I first look at this, it can be a lot. I'm going to take it term by term. There's my first term until I change both multiplication or subtraction. So looking in here, I know how to multiply 3 times 2. Now here's where we have to remember, now we're actually multiplying. Our powers could change. I have to multiply a single factor of x times x squared. And I know my exponents rules say keep the base, add the exponents. In my next term, now that I'm thinking multiplication, I need to think about how those powers may change. I know how to multiply 3 times 3, and x times a second x is x to the 1 plus 1, or x squared. And finally, that third term, 15 and an x. Now that everything's listed as term plus term plus term, a 3-term polynomial, now I need to switch back and see if any of them are like terms and I could combine them. But I see cubics or an x cubed. I see x squared's not the same kind of term for addition, and I see 15x's. That one's finished, and it's in standard form. Right, if you want to see how you're doing, pause the video and come back and see how you do on the next one. Maybe try it first. If not, do it with me, but pause the video so that you're not racing through this and not actually kind of thinking the math through. On the next one, the 3AB is my entire distributor. And that will have to distribute by 3 different terms because I have a monomial by a trinomial. I'm not going to worry about standard form here because I'm mixing variables. So in the first one, it's a 3 times a times b times 5 times a squared. That's a lot in the first term. I'm just going to leave it because I know I accounted for everybody in that multiplication. Minus, I've got a 3 times a times b times the actual a. Now I'm going to run out of room here, I hope not. In the last term, I've got a 3 times a times b times 2 times, oh no, b. So I know I've distributed by multiplication that 3ab. Now I want to go through and simplify. So that entire first term is all multiplication, so that together can be simplified into 3 times 5, a to the first times a to the second, keep the base at my exponents, and then I see a single factor of b hanging out in there. We'll keep him. My next term, I see a minus. Now, I only see a 3 as a multiplier that are numbers that I identify. Everybody gets their powers. So I have an a to the second b when I simplify that term. And finally, my last term, I see a 3 times a 2. I see an a by itself, and I see 2 factors of b. When you look through these, it's a little harder to tell if any of these are like terms, but none of them have the exact same combination of powers and letters. So the first one is a's cubed. I don't see any others with their a's cubed. So even though they have a's and b's, they're different variations of that, so they are not like terms for addition and subtraction. All right, these final two take 2 separate multiplications to happen. So as I look through this one, I see a distributor of 3 for the first set of parentheses, and I see a separate distributor of plus 6t for the next set. So I'm going to have to run this process twice and then see if any of the terms are able to be combined. And then my 6t is going to have to distribute here and here. So my plan for what I have to multiply for distribution is all set. I have to multiply a 3 by a 2 times a t squared for my first term, subtract my 3 times my, oops, I almost wrote 12. You can write 12 if you realize that that's what it'll be, but a 3 times a 4 times a t minus a 3 times a 15. I want to be very clear that my next distribution, whatever the sign is right here, it's important to distribute it with a sign. If that was a subtract 6t times all that, the subtract would have to count as a negative sign and be distributed with that. So in my next set, I'm going to need to distribute my 6t, so I'll have a 6 times a t times a 5 times a t. Add to that a positive 6 times a t times a 2. Everything's been distributed. Trying to show you a process where it seems like a lot to write out, but we're doing it correctly, and therefore we don't have to go back and do as much work to fix things up. In my first term, and I know I stop my term when I get to addition or subtraction, that'll become a 6 times t squared. Minus, in my next term, 12 times a t. In my next term, there's only 2 numbers, so that's a minus 45. And I can just keep going. My next term, I have a plus 30, and my t to the first times t to the first is t squared. So I want to make it very clear with those multiply dots that I'm in multiply thoughts. Plus, in my final term, 12t. So I'm done cleaning up my terms. Now I need to shift and think about simplifying. And in simplifying, I want to see if I can add any of these terms together because they belong together on a shopping list. So I'm thinking standard form, so I'm starting with my t squareds. If I look throughout the rest of it, I have more t squareds that I'm adding. Powers never change when we add, so I have 6 of them and 30 more of the same thing. So in my final answer, I'll end up recording that I have 36t squared. I have minus 12t here, and when I look further along, I have add 12t. Those are opposites. They make 0 t's in my final expression. And then a minus 45 constant that had nobody to combine with. And there's our final answer. So we went from this long expression that started up here down to 36t squared minus 45 as our final simplified expression. Why don't you try the last one here of this set, pause the video, and come back when you're done and compare and see how you did. If you need to stay with it, then I'll walk you through from the beginning. If you're still with me, then we're multiplying a 5 as our distributor for the first parentheses and a positive 2y as the distributor for our second set. So I'm going to plan my math first and then carry it out. I'll need to distribute to the first term, the second term, and the third term, and then that distributor's done. This distributor is distributing over a binomial, that 2 term. So when I start to multiply out, I'm going to have a 5 multiplied by a 4 multiplied by a y squared. Plus a 5 times a 5 times a y, minus a 5 times 2 for that first distributor. I can put a plus sign here because I know I'm going to take care of the sign plus and distribute it over. So I have a positive 2 times a positive, positive 2 times a positive y, sorry about that, times a positive 4 times a y, plus a positive 2 times a y times a 3. At this point it looks like a lot, so we want to take it in small bits. We're going to take it term by term. So I start until I come to a plus or minus sign, so that's the whole first term, and I recognize that that'll be a 20y squared, plus my next term continues till the subtract sign, 25y, minus 10, oops, a little too soon. That term needs to go all the way, plus 2 times 4, y to the first times y to the first, plus 6y. Almost done, except now that I'm done putting terms together and I just have a shopping list of adds and subtracts, I want to think about putting this in standard form and combining any like terms. So I scan my list for my highest power and I see that it's y squared. I see that together there'd be 28 y squareds, 25y here, and another 6y term here means I have 25 plus 6, 31 y's. And then my final constant has nobody to combine with. You're going to use all those skills in order to solve equations as your kind of finishing skill today. The reminder on here says to use order of operations to help you. Distribute or multiply over all grouping symbols, whether they're parentheses or brackets, before you combine like terms. So just like Aunt Sally, we multiply before we add and subtract. Keep your exponent rules in mind, but only when you're multiplying. So not when you're adding and subtracting terms, because when you're adding and subtracting terms, those rules don't apply. So to solve equations that have more complicated expressions in them, we're going to combine that skill and do it on both sides of an equation. And when you see this one, it's got quite a bit going on in it. But you can handle this. You're good equation solvers. So as I look through the equation, I'm planning out that first I have to simplify. And I'm looking for any distributors. So I always tell people that you're in simplify mode first. You're not in solve mode. We cannot go ahead and start adding and subtracting or multiplying and dividing on both sides until we have a much simpler equation. So as I move into simplify mode, I'm staying on one side of my equation only. So I have a 3 times a 2 times a c minus a 3 times a 3. Then I keep going and write the rest of my equation on that side. So when I'm in simplify mode, only one thing at a time. On the other side of my equal sign, I'm going to go ahead and distribute. I'll have a negative 4 times 2 times c. And you can put a plus, and then I start again with that negative 4 multiplied by 1. The distribution's done, and I still have a plus 8 on that side. very similar to what we did up above now. I want to look at them expression or term by term. That'll become a 6c minus 9 minus 1. Okay, so I'm still simplifying or cleaning up that side. I'm going to go to the other side and start to clean up that side. So negative 4 times 2 times c plus, sorry, I've been doing this, negative 4 plus 8. I am still in simplify mode and I cannot start solving, so each side is still very separate. On this side, on the left-hand side, I want to think standard form. I have 6 c's and no other c's to put together. Minus 9 minus 1 more. On that side, I can combine like terms. That's one expression. On the other side, then, I can combine like terms. So I have a negative 8c. It's the only c terms on that side, and a positive 4. What I want you to do is, and we're not done with this one yet, is indicate that from here to here, we were in simplify. You should see how hard it is to turn the smartboard to do that, like to rotate it. It's really hard. Then we can actually start to solve. So here on in then, now I'm going to switch to solve mode. And when you solve, you guys work on both sides doing your undo operations. So many ways you could approach this one. I'm going to start by adding 8c on each side to bring my variables to the same side, but you could have started with a few other things as well. And I will end up with 14c minus 10 is 4. You guys are really good equation solvers, so you could take over from here. I'm going to come underneath. Get all the way to where we get a value for c. So when you're in solve mode, that's when you start using those inverse operations. But you don't get to there till we get a much simpler looking equation than the one that they had started us with. All right, the final one. Final one over here. It's equation solving, so I know when I'm done I need to say W equals. I see a distributor on this side of 5. I see a distributor of 3. And I realize that before I can start solving, I have to simplify. So just like this side, we're going to be in simplify mode at first. So I need to distribute a 5 multiplied by the 9 that already has a W to the first next to it, plus 5 times a 2. It's the only things that are on that side. That was the only thing that needed to be distributed as well on that side. On this side, I have a 3 times an 8 times a W, minus a 3 times a 7, plus 17. I am still in simplify mode, so I want to go term by term and see what I can make of these terms. So 5 times 4, or 5 times 9, is 45W, plus 10. On my left-hand side, or my right-hand side, the other side, I want to go again, term by term. It's a 24W minus a 21, or plus negative 21, plus a 17. I'm still in simplify mode, so each side stays separate. Nothing's happening from side to side. So 45W plus 10, they are not like terms. So therefore, I can't combine them, and they just need to stay until I start solving. One has the variable, one does not. On the other side, however, the 24W's are the only variable term, but I have a minus 21 and a plus 17, so they combine to make negative 4. Now, so same thing that I was talking about before, up to here we are in simplify mode. Now we're going to switch over and actually be solving this equation. Now that we've got it as simple as we can get it on each side, now we could switch into that mode where we add and subtract on both sides to solve. I would choose to subtract 24W's on each side. I would choose to subtract 10 on each side next. I would then divide both sides by that 21, and this won't come out a whole number. Okay? In fact, when you simplify that, should come out negative 2/3, and there's our final negative 0.6 repeating would be fine as well. Please make sure when you're doing the assignment tonight that you realize that you have some problems from 8-1, meaning additional practice, and you have some problems from 8-2, so from 2 separate page numbers. If you pause the video right now, you could come back to this video when you get to the second day and you get to the very last problem, because I will work that through with you so that you can confirm that you did one that looks really hard, but you did it correctly and that you've got a good answer. So this one's from 8-2, number 16, and you can pause it now and come back to this when you actually do this problem, or you could do this problem first on your paper, realizing that you have some parts of 8-2 done then. If you want to switch the variables to x's because the a's are bothering you, that is fine. I'm just trying to quickly write the problem up here. Okay, got it. I see a lot of distribution in here. This will be that last problem on the last part of 8-2. I see 1 distribution, 2 distributions, 3 distributions, 4 distributions. That's a lot of distributions. It's not going to be that bad, though. I'm going to throw my arrows overboard so I know how many multipliers I will need. This one's going to clean up very quickly. I have a times a plus a times 3 plus a times a, either plus or you can do a minus here, a times 6 plus 35. I have an a times a minus an a times 5 plus a times a plus a times 7. If I go too fast, you just need to pause the video and catch up. We are in multiply mode, not adding mode at the moment. That term, that individual term, becomes a to the second plus 3a plus a to the second minus 6a plus 35. On the other side, that becomes a to the second minus 5a plus a to the second plus 7a. I'm not in solving mode yet. I'm still in simplify mode. So on my left-hand side, I see 1a squared, and down here I see an additional a squared. So I'm thinking standard form, switching from multiply mode to putting these together by addition. I have 2a squared. And my next, I have 3a's minus 6a's, so minus 3a or plus negative 3a, plus 35. On the other side, I see an a squared and another a squared. Remember, that's 1a squared, so 2a squareds, minus 5a plus 7a plus 2a. Now you can actually go ahead and start to solve. What sometimes throws people is that you've got a squareds in here. So we've not usually solved with a lot of a squared, so I'm going to take 2a squareds off both sides. My a squareds disappear. In other words, they zero out. I have negative 3a plus 35 plus 2a. I think instead of moving that 2a, because I don't want to create a side that has nothing on it, I'm going to add 3a on this side and 3a on this side. I know it's not the side a lot of you like to work your variables to. 35 equals 5a. Oh, you're in the home stretch. Divide both sides by 5. And a is 7. And we'll see you soon.